Final example, what is I cubed? I to the fourth, I to the fifth, I to the sixth, I to the seventh, I to the eighth, blah, 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 blah. What pattern appears as we go through these powers of I? So let's take a look at how as we work through it. So if we have I to the 1, just plain I, we have I, right? That's just what it is. It's just I. What about when we have I squared? Well, by definition, that was -1. So let's see what keeps going as we up this up. I cubed, well, we multiply the one of us by one more I, so we'd get -1 times I, or just -I. I to the fourth would be equal to I times I gets us -I squared. I squared cancels, and we get +1, right? -I squared, that cancels, and we get +1. So we're left at 1. Just a good old +1. What if we keep going? I to the fifth is equal to, well, we multiply by 1, so it's just I once again. I to the sixth would be equal to I squared, multiplying by one more I, which we know is -1. I to the seventh is equal to I cubed, which is equal to, hey, we already figured this out. That was -I. I to the eighth, well, that's going to be equal to I to the fourth, because we can just multiply the one above. Hey, we already figured out what I to the fourth is. That's going to be +1. Make that plus sign a little clearer. I to the ninth, if we just kept going, we'd have I to the fifth. Hey, we already figured out what I to the fifth was. That was I to the 1, which is just I, and so on, and so on, and so on. So the pattern repeats. Every 4. So what we need to do is we basically need to divide by 4 and see what we've got. So what we can do is we can divide exponent of I by 4. Then, well, what do we do next? Let's do a quick check. If we did I to the ninth, so 4 goes into 9 how many times? It goes in twice. So we'd have 8 minus 8, 1. So we'd get a remainder of 1. So then you look at remainder, and that tells you it's equal to I to whatever you just figured out your remainder is. So for example, if we wanted to figure out what I to the 80th is, which is divisible by 4, right? So we can see, oh, that's just I times 4 times 4 times 4 times 4. If we figure that out, I to the 80th, then we can figure out that what that is equivalent to by 4. How many times does that go into 80? 4 goes into 8 twice. So that gets us 8 minus 0, bring down the 0, 0. We get 20, and our remainder is 0. So that would be the equivalent of I to the 0th, which is just the same thing as I to the 4th, which is +1. So that's how you want to do if you're given a really, really, really large I. It's just a question of if you divided it by 4, what would be left over? What would be the remainder? And if you wind up having a remainder of 0, then it fit perfectly, so it winds up coming out just as 1. All right, great. We'll see you at Educator.com later, and we'll finally see how complex numbers tell us something about polynomials more than just quadratics. We'll see how they're deeply connected to everything that we've been talking about. It'll be so deep, it's called the fundamental theorem of algebra. All right, see you later. Bye.